In the part 1 of this video about application hosting, we covered some basic but necessary details about hosting your applications in Sevalla. In this video, we want to talk about a little bit more advanced stuff, more features and more capabilities that is provided to you by the Sevalla platform. We are going to talk about process management, scaling strategies, persistent storage, monitoring, and a lot more. So let's get started. Going back to the documentation, let's talk about processes first. Processes are the foundations of application hosting. So let's start from here. In Sevalla, processes are the smallest unit you can deploy. You can think of processes like that. Think of them as different parts of your application that can run independently and scale separately. Okay, those are very important terms. The first kind of process that you can have is a web process. Every application, it starts with a web process. This is the heart of your application that handles HTTP requests from users. Now, the web process runs your application and serves it to the world. Some of the important properties that you should remember about the web processes: you can only have one web process per application, because web process is the exposed entry point that your users are going to interact with. That's why you can only have one web process per application. And by default, your web process is assigned and exposed at the port 8080. If you go back to our dashboard, here we can see that our application, the Next.js application that we just deployed in the last video, it is exposed in the port 8080. Even though we don't get to see that, if we click on the visit app button, we only see the domain that is assigned to us. We don't see the port. We can customize it if you want. The second thing you should remember is you cannot remove the web process. It is mandatory, it is required. And by default, the web process, it is accessible over the internet using port 80, which is for HTTP, and port 443, which is for HTTPS based requests. Now, going back to our dashboard, let's go to processes, and clicking on web process, if we click on update process, there are a couple of things that we can update here. The first thing is, obviously, we can update the name of our process, which is web process by default, but we can assign something else like a primary or something like that. The second thing, which is an important part, is the custom start command. If you assign something here, this basically tells Sevalla how to start your web process or how to start your application. For example, if you have Node.js, it will be something like npm start. If you have PHP, it will be something like PHP index.php, or for Python, it will be something like Python. By default, you don't have to provide it. It gets automatically assigned. But if you want to customize any of your own workflows, then you of course can do that. The second thing is the health check path. Now, this is important for zero downtime deployments. If you assign this to a HTTP endpoint, which returns a 200 status code when it is requested. So using this, Sevalla can deploy new instances of your application without causing the old instances to go down. This is important if you want to ensure zero downtime deployment. The next thing is horizontal auto scaling. We'll get to this shortly, so let's ignore this part right now. And the last thing is the instance count. This is the controls that is given to you for scaling depending on your needs. In my opinion, here the only thing to customize for you is the health check path. This is pretty important because Sevalla checks this path every 10 seconds during the runtime. And if it fails 3 times in a row, then the Kubernetes pod that is running your application, it will be restarted automatically. So during deployments, the old pods keep running until the new ones pass the health check, which ensures you get zero downtime deployments. So if you want to customize that, you can expose a HTTP endpoint in your application and return a 200 status code from there and define something like /health/status here. The next thing is the background worker. Background workers are basically processes that run separately from your main application. They don't have any kind of relation, any kind of effect on our primary application. They are perfect for tasks that should not block user requests. For example, image processing, email sending, or data synchronization, or any long running computations that you might have. Some of the properties of background workers are, for one, they run non-stop. They run continuously in the background. So they are a process in itself without affecting our main process. The second thing is they are not accessible over the internet. They are not exposed to the outside world. Only your application can communicate with that or access that. Third is every worker or every background worker needs its own pod and resources. So again, which ensures that your main or primary application is not affected. It is run in a separate pod in itself. So if you have queue processes like Redis queue, for example, for Node.js based environments, we have this library called BullMQ, and you can use BullMQ to host a separate background worker in a separate process so that it can handle things like email sending and data processing, image processing, etc. So let's go to our dashboard. We'll try to see how it looks like. When you come to your app's dashboard, you can click on processes, and here in this screen, you can click on create process. Here you have three different options. We'll talk about what is cron and what is one-time job. But for now, let's click on the background worker. Here we'll get a couple of options. The name will say the data processor. The custom start command. Start command is basically in your application. If you are using a Node.js application, for example, in package.json, you will have a script to start your background worker. The same way you have a script to start your primary application using something like start or dev. The same way we'll have a script or command for starting our background worker. So we'll have to write that command here. In our case, it will be something like npm run worker. Okay, I'll show what the code looks like in a bit, but for now, let's create this. The instance count 1 seems fine, and the instance size, let's keep the standard size, right? The recommended one. And let's click on create, and that will create a background worker in our process with our web process, which was already there. And when we make this change, we'll get this prompt that you have undeployed changes if you want to deploy your background worker that you just added. So we'll wait a little bit before we click on this, because we actually have to push the code that actually contains our background worker. So we'll not deploy at this moment. We'll come back to this, but we have added a background worker process. Next, let's talk about the third kind of process, is the cron process. Now, cron jobs, if you have heard of them, they are scheduled processes, which means if you want some kind of task, some kind of API or any kind of script to run at a particular point of time, at a particular point of day, or at a particular point of date, then you can use cron job. Let's say every day at 12 a.m. at the midnight, you want to clear up all your users' archived posts, something like that. If you have a requirement like that, then cron job is a very good use case for that. We can perform things like regular maintenance, report generation, data cleanup, or any kind of recurring operations using cron job. One thing to keep in mind is, by default, cron jobs run in UTC time zone, but you can set a custom time zone using identifiers depending on what you need. This is important if you have business critical scheduled tasks. So you have to be mindful about the time zone that you are configuring for. You can also trigger your cron jobs manually by clicking on the run now button that is given in the dashboard if you want to test your cron jobs, right? And the last kind of job that we have is just called a job process, and you can also call it as a one-time job. Now, one-time jobs, as the name suggests, this is one-time process that are run at specific deployment events, and they're very useful for things like database migrations or cache clearing or sending deployment notifications, etc. All in all, there are 3 different points of time where you can run these one-time jobs. One is before deployment, second is after successful deployment, and third is after failed deployment. Now, talking about when we might need what kind of one-time jobs, If we talk about before deployment, then this is more suited for things like performing database migrations or doing things like pre-deployment checks if you need them. Same way, after successful deployment, you might have one-off jobs for things like cache warming if you have a use case like that, or just sending success notifications to your Discord or Slack. Same way, after failed deployment, you might want to trigger jobs that do things like rollbacks or send alerts to your systems or send alerts to your Slack channels. So these are some of the use cases that you might need for one-time jobs. The most common use cases are, of course, the database migrations, and the second is sending alerts. And the thing to keep in mind is these one-time jobs, they run when needed at a particular deployment event, and they are shut down automatically after they are complete. And you are only charged for the time they actually run. So they are pretty cost effective for occasional tasks when you need them. That's all about different kinds of processes that we have available. So if we go back to our dashboard, we already saw how to add a background worker. What are the options available? Same way, if you want to take a look at what are the options available for cron. This is similar. If you want, we can name the process something like maintenance if you want to run it at midnight. Again, we need a custom start command, which is inside our package.json. A cron expression. To define a cron job, you have to provide an expression, which is fine if you don't know them. In the info, you can find a lot of help about how to configure it. And if this is also not enough, you can consult various tools online which take a natural language and provide you with the cron expressions, right? And this is an option to provide your own custom time zone. And as usual, for every process, we have to provide an instance size, and here we can select that. Okay, we'll not configure a cron job here. And if you want to take a look at the one-off jobs, it also has the same kind of fields. You can provide a name, you can provide a custom start command, you can provide the deployment event that we are talking about. The first is before deployment, as I talked about, then after successful deployment, and another is after failed deployments. Okay, and again for instance size. That's pretty much all about different kinds of processes that we have available in Sevalla for different kinds of use cases. Now, the next thing that I want to talk about is also very important is scaling strategies, which is one of the most critical aspects of any production applications. Sevalla offers two different kinds of scaling strategy depending on your use case. One is vertical scaling and the second one is horizontal scaling. Now, understanding when to use which is very important. That's what I want to talk about in this part. Understanding what kind of scaling means what is pretty straightforward. The first one is vertical scaling, which basically means that giving more power to your existing process. Basically means just increasing the amount of CPU or increasing the amount of RAM of your process. That's what we call as vertical scaling. So if we go back to our dashboard here, let's click on web process, and by clicking on update process here, if we go from hobby to our standard instance size, which makes our CPU from 0.3 cores to 0.5 cores and makes our RAM from 0.3 GB to 1 GB. And when we do this, it's called as vertically scaling because we have the existing process and we just increased the power, increased the processing power and the memory power of our existing process. That's what we call as vertical scaling. Now, the second kind of scaling is the horizontal scaling. And horizontal scaling means running multiple instances of the same process. So instead of one powerful server with say like 4 CPU cores and 16 GB of RAM, you'll have multiple smaller ones to handle a load when you have a user spike or any instance like that. And this is how it works if you want to understand the horizontal scaling process. Every time, so you have multiple users all over the world, right? And this is the internet, let's say. These are the different instances of your web process that are handling the load, handling the user requests. The users are sending their requests and you're getting them. The first point of contact that happens is the load balancer, Sevalla's load balancer, which receives all your requests. Then what it does, it has, let's say, there is a load balancer here. It distributes all the requests across all your available instances. These are the 3 instances we have available. Then depending on if this instance is already handling, let's say, 500 requests, and this instance is handling 200, this is only handling 50. Of course, there are a lot of complicated load balancing algorithms that are available for load balancers, but just speaking logically, we can imagine something like that. So depending on the availability of the instance, the load balancer will decide the next request should go to which instance, right? And if one of the instance fails, the traffic which it is getting, it will automatically go to the other instances, so that you have 100% availability all the time. And new instances can be added and removed as you wish. There are no rules to that. So for manual scaling, we have 2 types of horizontal scaling available for us. One, if you look at here, we have the option to increase our instance count. So if you want, we can, let's say, increase it to 4. So 4 instances of our web process will be running, and our load balancer will distribute the requests that we are getting from our users across our 4 instances, depending on the availability. This is the manual scaling. But if we don't want to do this, if we don't really know the behavior of our users, then we also have an option for horizontal scaling. Now, when we enable this, this is very powerful and very convenient feature, the horizontal scaling part. This feature basically monitors your CPU usage, and it scales your instances automatically depending on the usage of your CPU and memory, of course. And it is very easy to enable it. You just have to switch it on, enable horizontal scaling in any of your process settings. Then you have to set a minimum instance count. You want to say at all times, I want to have at least 1 or at least 2, right? This is your minimum instance count. You cannot go below this, even though it is automatic. And you will also have to set the maximum instance count. So if your application traffic requires it, then maximum how many instances you want Sevalla to scale it, basically. And this control is given to you so that you can control your costs, right? If you, let's say, increase it to 20 instance of your application, and you get a lot of user traffic, and of course, Sevalla will be able to handle it because you have given this option to scale it automatically to 20 instances. But your costs will increase accordingly. So you will have to decide for your own use case, for your own team, and define your maximum. Whenever CPU usage hits 80% across all your instances, Sevalla will automatically add 1 more instance to your account, depending on what is the maximum amount you have allowed Sevalla. And same way, when usage drops, the instances are not needed anymore, it will scale down, and minimum it will keep 2, and it will not go below that, but it will automatically scale up and down depending on the user traffic and the CPU usage, basically. Some of the best practices, if you want to remember for scaling, is always begin with S1 or S2 pods. And by S1, I mean these. Begin with S1 or S2 pods when you're starting out. Then monitor your application analytics. And if you notice something, if you notice some limitations or some resource limits, then you should scale up consistently, depending on the performance of your application, depending on the real data. Same way, for deciding between horizontal scaling and vertical scaling, I would suggest use horizontal scaling for stateless web applications and use vertical scaling for databases and stateful processes, basically. And of course, you can combine both of them, vertical scaling and horizontal scaling, for optimal amount of performance, and also depending on your cost, how much budget you have. And when it comes to costs, you should always remember that you only pay per second of usage. And if you have enabled horizontal scaling, then you can save some money when you have low traffic, because you are not overestimating your traffic by using vertical scaling. You know how much traffic you usually get by using vertical scaling. Instead, you let Sevalla handle it by monitoring your CPU usage. Another important thing that we should talk about is adding persistent storage to your applications. Because by default, Sevalla applications are ephemeral, if you may, which means that when they restart or redeploy, any files that were created during the runtime, they completely disappear. But there are some cases when you need data to persist between two different redeploys or two different restarts. That's where we need this feature called persistent storage. For example, there are some use cases for persistent storage, which is store user files. User files like user uploaded images or user uploaded documents or user uploaded videos, even though you should be using object storage for this use case. But let's say you have some kind of specific use case where you want to store it in the file, then you can use persistent storage for your use case. The second, local database or cache. If you use something like SQLite or some kind of local file-based cache, then also you can make use of persistent storage. Same way, if you store your logs in files, then persistent storage can help you retain those logs over a long period of time, right? So these are some of the common use cases where you might need to add a persistent storage to your application. There are also some of the things where you should not use a persistent storage for. For example, for keeping user session data, never use persistent storage for that. Always use something like Redis or database, which are much better choices. Same way, if you have a use case for temporary processing files, then also using persistent storage is a bad idea. Or if you have cache that can be regenerated, then using persistent storage is not a good idea. It's not worth it, in fact. And the last thing is static assets. You can store static assets using persistent storage, but that defeats the whole purpose when you redeploy, when the assets change. CDNs are much better for this use case and offer optimal amount of performance and the least amount of latency for delivering your static assets across the world. So let me show you how you can add persistent storage for your application. You can come to your application dashboard and go to disks, and here there is a button called create disk, and by clicking on this, it is asking for which process that you want to attach this storage basically. So let's say we want to attach to our web process, and this is the mount path, basically where you want this storage to live. Now, depending on whether it is user uploaded files, whether it is logs, whether it is application data, you can choose different locations. And the last is the size of the storage. Depending on the size, you will be charged accordingly. For 10 GB, it is $3 per month, and for 20, it's 6, and so on. So decide what size you need and add your disk accordingly. Next thing that we want to talk about is the analytics. How can you understand the analytics that Sevalla provides for your process? On the top right, we can select for which process that we want our analysis for. For example, if we select our data processor, which we have not deployed yet, for that we have 0 analytics. But if we choose our web process, which is already deployed and we only have access to it, so there is not a lot of analytics data available here, but it is enough to understand what is happening. For each application, you get detailed insights into the memory usage, which is basically the RAM usage, and the CPU usage, how much CPU you are processing, how much CPU is getting used, the instance count, how many instances were assigned at what point of time, if you want that kind of data, how many requests per minute that you got, the response time, and also the slowest requests sorted in descending order, so that you can quickly find out which of your requests are taking a long time. Right? And also the top pages, which shows you which are the more popular pages in your application. Now, if you take a look at the memory usage, it shows the average RAM consumption over time. And it is very important if you want to identify things like memory leaks. And it also helps you determine if you need larger pods, if you need to scale vertically. The same way, the CPU utilization chart, it shows you the average CPU utilization as a percentage, how much percentage of CPU that you are using at certain points of times. And it is relative to your pod's CPU allocation, of course. And this is important for deciding whether you need to scale horizontally. You can take a look at the RAM to decide whether you need to scale vertically, and the CPU usage will help you decide whether you need to scale horizontally. You should watch for sustained CPU usage. If you are consistently above 80%, then you should consider scaling up or scaling out. Scaling out basically means horizontally scaling, adding more instances or enabling auto scaling. Spiky CPU usage basically indicates that you have inefficient code, some kind of, or some code which might need background processing. You should also keep that in mind. Then we have instance count, which, as I said, it shows how many instances are running at different points of time. This is particularly useful if you have auto scaling enabled, and you can use analytics pretty effectively with a certain rules if you have established in your team. For example, you should set up some kind of daily monitoring for checking response times and error rates, and you should also monitor resource utilization over time to understand your systems better, and also try to identify traffic patterns. This should be your daily strategy. Similarly, for weekly strategies, you should take a look at slower requests that we have here, and also review how your scaling strategies are affecting your system, whether they are working or not. And if needed, you should consider your capacity increase or decrease depending on the results. And monthly, what you can do, you can review your bandwidth and your costs, and you can optimize your resource allocation. And depending on that, you can plan your next steps, whether you want to scale up, scale down, vertical scale, horizontal scale, and etc. Another thing that we have available in our dashboard is logs. Logs are pretty important if you are trying to debug your system, if you are trying to understand your system in a deeper way. And Sevalla provides pretty comprehensive runtime logs if you are trying to log it. As you can see, we are not logging anything at this moment. That's why it says waiting for logs. But if you're logging it, all your logs should show up here. This page typically shows the last 500 lines of your runtime logs, and it covers from 15 minutes to the last 24 hours of logs, and all the severity levels if you are doing structured logging, the info level, the warning level, and the error level. And this screen gets updated in real time whenever we get new logs in our application. You don't have to hit refresh manually if you are trying to monitor something. You can also filter your logs based on the process. If you only want logs for your web process, then you can do that. Same way, if you want to filter by the duration, you can also do that. Or you can do some kind of search, some kind of keyword search, or you want to search some kind of ID. So you can also do that. Next up, we also have a web terminal available to us in our application dashboard. And this terminal is basically the direct line into our application's container, the exact space where it is running, the exact location in the Kubernetes cluster. And it is pretty powerful for things like debugging or file inspection or emergencies fixes if you need them. And here we can run any kind of Linux commands that you want. Let's say we run ls, click enter. Here we can see the content of our application, the application that we have deployed. If you want to check what are the processes that are running, you can run the ps command with a ux, and here we can see that a lot of processes are running, npm run command, the next JS server, and so on. And let's say if you want to check the node version, node-v, and we can see that the node version that is deployed here is the version 18. We can check a lot of things since we have direct access to the terminal. We can run any kind of commands, and we can debug things, we can change things, we can update things. It's pretty powerful in a lot of scenarios. With that, we are done with all the concepts that we wanted to talk about in this video. Let's do a demo now to consolidate all our knowledge. We have an application here, which is a modified version of the Next.js application that we deployed in the last video. Here, I have added two APIs. One, here we are doing some kind of background job processing. If we go inside the redis.ts file, here we are initializing a Redis instance, and in the q.ts file, we are using this library called bullmq, which is a background job processing library, and we'll be running this particular background job processor in a separate background worker that we created at the start of this video. Right? We'll show how that will work. Here we have a sample worker, which is a data processing worker. Of course, this is purely for demo purpose. We are not actually doing anything. They're just showing how a background job processing worker can work using BullMQ and using our Sevalla background feature. Now here we are just simulating some kind of job processing and we are updating our progress every time and returning the response here. Right, we have added some kind of logs here, and this is the entry point which starts our worker. We also have two API endpoints, one for triggering a new background job for processing our data, and the second one is to get the status of an existing job. And finally, we have a page here so that we can quickly test how all of this is working. We don't have to understand the code. We are just focusing on how background workers work in Sevalla itself. If we take a look at the package.json file, this is a start command for starting our web process, our Next.js process basically. And this is the command which we had added here. If we go back to our dashboard and processes and the data processor, we edit this, update this. So we had provided this command, which is npm run worker. This command will in turn trigger this script, this worker, basically, which is the index.ts, which is the entry point of our data processing worker, which is going to run in a separate process from our web process. I have already pushed this into a new branch called background. So we can go ahead and deploy that. But for that to work, we'll also need a Redis instance. Because here, if you see, if we go inside the redis.ts file, we're using a Redis URL provided to us by an environment variable. And in local environment, of course, I am passing a Redis URL, which is not going to work in our production environment. That's why we have to create a Redis instance. And Sevalla offers us a way to create a Redis instance. So let's go ahead and do that. First, going back to our dashboard, let's go to databases, create a database. Click on Redis and the database name is fine, whatever it is. Password is also fine. Name we can keep as default, Mumbai. This is the same region where my application is deployed to ensure that it has the minimum amount of latency. And resources, the default one is fine for now. And let's click on create. After this is created, I'll just go ahead and copy the internal connection URL. As I had mentioned in the previous video, databases and object storages inside Sevalla, they provide two ways of connecting to them. One is using internal connection and another is for external connection. External basically means anyone from the internet can connect to this database. Internal means only the applications inside Sevalla, inside a particular company, can connect to each other. All the bandwidth produced in the internal connection is free. So it's a no-brainer that we are going with the internal connection. I have copied the URL by clicking on this. Now I'll go back to my application. Is this my Next.js app? And I'll update the environment variable. Let's add an environment variable, which is called Redis URL. And I'll paste the URL here and click on save. Now this will be available to our application and we can connect to Redis. One last thing that we have to do is, let's go to overview. We have to connect our web process, our application to our database. And we can do that in the dashboard using add connection. So let's select our Redis instance name and click on add connection. After we have done this, if you click on overview, we can see that now our application can connect to our database internally. This is not exposed over the internet. They can connect internally. And now that we have our setup ready, we can go ahead to deployments, do a manual deployment of our background branch. Click on this background branch and click on deploy application. This triggers a new deployment. Let's click on this. And after a few minutes, we can see that first, our web process is deployed successfully from this message and this next server is started. And the second thing, we also see logs for deploying our data processor, our background worker basically. Here we can see that this command is run, which is tsx worker/index.ts. And we see that data processing worker started and listening for jobs. And it is successfully able to connect to Redis using the internal connection that we defined. So let's visit our app and we can do a quick test of how it is working. The route is /demo that we had defined. And here we can simulate some kind of background data processing. So if I click on process JSON data, here we see that after we click on this, the job ID is 1 and we get a message that data processing job is queued successfully. And if we click on check job status, we again hit a new API and it says that our job is successfully processed and some random data. And if we go back and click on logs, here we can see all the logs that we got. This, if we want to filter, we can filter by our data processor. And here, this is the log that we got after our background worker was deployed successfully. And these are the logs that we got after we tried to simulate a data processing job. So our background worker picked up the request with JSON data processing. And these are the progresses, 10%, 20%, 30%, all the logs that we are doing. And finally, our data processing job was successful. So let's say we go back and trigger another job, process a large request and go back to logs. Here we see our logs getting updated in real time, getting another request and our progress from 10 to 100. And finally, job 2 is also completed. And if you go back to our UI, check job status, this also says our job is completed. So this is how our primary application, our web process, is communicating with our background worker. It is sending jobs to our background worker, which is running in a completely different instance. And it is able to process all our jobs in the background using a Redis instance, which we also created using Sevalla, and all of it is working great. And that's pretty much all we wanted to talk about in this video. In the next video, we'll talk about networking and